Hello guys, and welcome back to my YouTube channel. Today we won't be troubleshooting, but we will be configuring this topology right here, this enterprise network implementation with a hierarchical design. So this is the core layer, the distribution layer, and the access layer. We'll be configure everything from scratch. As you can see, everything is down. And then let's actually remove. Let's remove that, and then let's just have a connection here. Perfect. Now be our internet, right? And we will be doing it using MOPS. And what MOPS is just method of procedure. So basically, we'll have some instructions here, right? So hostname. So here, just an example. So MOP basically is the method of procedure. It allows you to just copy and paste everything that you write in this notepad, ++, it's the best. So let's say you write conft, and then let's see, hostname, and then whatever you want to name it, right? Now you can just right? You can just copy and paste this into each device instead of having to manually type in enable conft hostname followed by the hostname. So it just saves manual labor as well as removes human error in case you accidentally mistype a command and then it doesn't work. It also allows you to see the steps that you actually took to actually do the troubleshooting on the configs to see where you went wrong as well. But yeah, let's go ahead and get started. Right? Let me enlarge this. So initial device setup in LLDP. These are our instructions basically. This split screen. More perfect, right? So let's just do this. Copy this as the title. So it's always going to be enable and then conft. Now in global configuration mode. So first let's do hostname. We'll do hostname last because we'll have to do it for each one of these. So let's do LLDP run. And what LLDP is, it's a vendor neutral or industry standard for neighbor discovery protocol. So it allows you to discover directly attached neighbors, get information like their native LAN, the type of LLDP that they're running, software version, duplex, hostname, the port that you're connected to on their side, and then the local port that they're connected to on your side, on the device that you're connected to. Pretty good and very useful. We'll be using it a lot in this configuration of the topology. Right? And you enable it using LLDP run. And then basic security. So enable privilege exit. We'll do secret. Console password line con 0. Do Cisco exit, and then service. And then this is another thing that I wanted to bring up as well. We can have, because sometimes the syntax is a little different. So I like to have like a extra router and a switch down here. That way I can just copy and paste the syntax exactly word for word so I don't get anything wrong. C service, encryption. So this encrypts all future and current passwords in the running config. Let's just do this, service password encryption. And then we will do the host name. Host name. And here we'll do with the access switches first. And then we won't put a number because it will change every time we copy it and paste it into it. So let's just run through it again. So we're in user exec, then we enter privileged exec, global configuration, we enable LLDP, create and enable secret for the privileged exec, the line console 0, we enter line configuration mode, and then here Cisco, it should be password Cisco. So this is another thing good about a mop. It allows you to actually troubleshoot or see where you might have went wrong before putting it into an active production environment, right? Password Cisco, so it allows you to test it before running it into, again, the production environment, even though it's packet tracer, right? Like, good to build some good habits. Line and VTY, right? So exit, and then let's do line VTY 0 through 15, password Cisco, exit, right? So I missed the VTY. So now we have it. All plain text passwords. We'll exit out of line VTY mode. Service password encryption, host name. Perfect. So for now, this is our things, right? And then we'll just paste it into the running config, or not the running config, the devices. And then look how easy it is. Oops, let me do this. Do one, perfect. And then this is how it's gonna work for each of them. Right now I'll show you the multi-layer switch as well as the core router, or the core, excuse me, the distribution switch and the core switch. How it looks like, since we're gonna have to change the host names. Let me just show you that really quick. Exit out of that. Exit out of this. Go into our mop right here. So here we will just do this. Then this switch 1. Let's remove the 1. And then let me turn it on actually. These ones you have to. You actually have to wait. Alright, no. And then paste it in. Again. 1. Alright, see how easy it is? So I'll cut it right here and then I'll come back to you once everything is configured with the basic mop that we made, okay? See you in a few minutes. Alright, I'm back, and as you can see, they're all labeled, as well as if we click on them, distro switch 1, let's do a core switch 1, a random access switch, perfect. Alright, now let's move on to the second part of the configurations. Let's do this. So shrinking. Alright. On all switches, alright, create VLANs, and then assign their ports. So first let's do this, and then I'll show you how to use LLDP to actually assign the ports to them, okay? Here, so we'll assume they're in global configuration mode. So we'll do VLAN 10 name staff exit, VLAN 20 name IT exit, VLAN 30 name admin exit, and VLAN 90 VLAN 99 name. Oops, this should be here, and then there should be exit. So let's copy this. All right. And then we'll do this because this one will change with all of them. Let's see. Before we actually do it, let's just go over it one more time, just to confirm. VLAN 10, name it staff. We exit out of VLAN mode, VLAN configuration, enter VLAN 20, name IT, VLAN 30, name admin, exit name, exit, VLAN 90, servers, exit, VLAN 99, name management. Yep, perfect. All right, let's go ahead and get them created. So conf class, and see it's already working, right? The password that we sent, or the enable secret that we sent, the enable secret command that we configured is working already. So the password will be class here. Do conf t, and then we will paste this. Do show VLAN brief just to confirm. 10 staff, IT, admin, servers. Perfect. Right, and then let me do it on this one just to show you how we're going to use LLDP, and then I'll do it off screen. T, paste this. Do show VLAN brief just to confirm. 10. All right, and then do show L. So this is do show LLDP neighbors, but this is the shortcut version, right? So we can do here. Actually, it's only these that should do it. We just need to create the VLANs on these multi-layer switches. So yeah, I'll create the VLANs and then I'll assign them. Actually, let's do that now. You show. Actually, an easy way to do it as well is going preferences, because it wouldn't show. So it's 1 and 2, 1 and 2, 1 and 2. Well, these are just 1. But 1, 2, 1, 2, 1, 2. These are designed. Then we'll enable these. So here we'll do four sets. So excuse me. So this is one set. 4 devices are one VLAN, the second VLAN right here, third and fourth right here. So let's just add some color just to make it easier. All right. And then And the last one. Right, so these should be the VLANs. So let's actually add that to the mock now. So they're currently in, let's exit out of this. Currently in global config mode still, because we just exited out of LAN configuration. We'll do interface range. I'll type it in here fully, 1 through 2. Switch port mode access. Switch port access VLAN, and then we can leave the VLAN not named because it's going to be changing. So let's go to here, paste it here, and then this one we will do 10. And actually, let's label them 10, 20, 30, and then this will be VLAN 99, this will be VLAN 90. But yeah, that's pretty much it. You'll just copy and paste this mop that we have here, well, this one right here, into these switches here, as well as, and then paste these right here. Let me just, this right here into the rest of these switches. So I'll pause it here and then I'll get back to you once I'm done, okay? One more thing I forgot to mention. Configure these ports for switch port mode access and enable spanning tree port fast. So we'll do that now. Tree, and then there's a hyphen in there, so let's just do it like this. So what spanning tree port fast does is it prevents it, or doesn't allow it to go into the listening and learning. It just automatically starts forwarding. So let's do interface spanning tree port fast. So we'll copy this. And then that should paste as well. Yep, alright. So let's get exit out of this. And then we can add it here. Spanning tree port fast. So we'll copy. Let's move this one. Right here. And now we'll be able to actually add the VLAN ID as well. So this is what we're going to copy and paste into the switches. This interface range right here will only be for the access layer switches. So this right here, only access layer, and everything above it into all these switches above, okay? I'll get back to you and then we'll do trunking, okay? All right, here, I just finished doing this right here, as you can see. Then we'll do trunking. Configure the links between the access switches and the distribution layer switches and the core switches as 802.1q trunks, ensuring only VLANs 10, 20, 30, 90, 99 are allowed. All right. So first we'll have to do, we're assuming we're in interface configuration mode. Let's just exit. So interface configuration mode. Interface range, and we're going to use LLDP to get the range itself. We'll do switch port trunk, switch port trunk load VLAN, and it's just VLAN, not VLANs. 10, 20, 30, 90, 99. Alright, now let's go into LLDP to actually, or let's see. So So it looks like they're all the same, but just to show you, because here, these ones you might not be able to tell. So here, do show LLDP neighbors. Like here, it tells you each one. Give me 1 second, right? Because I guess I forgot to do these, the distribution ones. Just this one. So let's just, yeah, I guess I just got distro number 2 that was wrong. Yeah, just confirming really quick. Yeah. All right, let me copy and paste. Going to our mop here. Oops. Control C. Go into here. Paste up host name. We'll do distro switch to. Alright, do show LLDP neighbors. Perfect. And then ASW1 and 2 should be there. Perfect. Right, so this is going to be LLDP. It allows you to show the interfaces that we're going to configure as trunk. These local ones are the ones that are locally on the device that you're on. The port ID is the one that it's connecting to on the other devices. So here you can see gigabit 0/1, that's here. Oh wait, here, excuse me. This is access switch 2. See, it connects here, and then it's going using this interface right here. So it's just an easier way to get a mapping of the network without having to have them all labeled, okay? But yeah. So for now, let's just make this. Let's just run this command again. Perfect, and it looks like it's uniform. So they're all using 1 and 2, 1 and 2, 1 and 2, 1 and 2. So we'll configure them as trunks using our mop. Interface range G 1 through 2, and this is just for the access ones. Here it will be different, right? Let's copy this, Control C, and then let's paste it into the CLI. Oops, paste. Perfect. See. All right. So now this one's done. Let's do this one really quick, and then I'll show you how to use it over there in the middle because it's gonna be different. Let me add exit as well to this one. Exit. So let's just take this one here. Exit. So this is going to be different. This is going to be for the distribution one since these have a lot of connections. So do n class conf t do show neighbors. So here these are all of them. So it's 1 through the highest one. It looks like it's 7 right here, right? So 1, 2, 3, 4, 1. Yep, 7. So we'll do interface range here from 1, and then we'll change this to 7. We'll copy this. We'll do paste. Do show. So it looks like it did it, but for only 1. Interface range not validated. Oh, I see why. So it is. So it's G10. There we go. G slash 0, 1 through 7. This one should work now. See, paste it here. Perfect. See, now do show interfaces trunk and perfect. So now I'm going to do it for the rest of them, and that's how you do it using LLDP. But I'm going to do those off screen since it's pretty much just copying and pasting this into them, okay? All right, just got done, and just to show you, do show neighbors, do show interface trunk. So here it shows you 1, 2, on, and then I'll run that on most of them just to show you. Do show. So both. Same thing here. And these are all going to be the same. Let me just show you these because these are the ones that are different. So see, 1 through 5, 1 through 5 on trunking, and then the allowed VLANs all match up. Is this just copying and pasting once you have the command? Same thing here, 1 through 7, through 7. Let me actually show you. Same thing, 1 through 7, through 7. I'm pretty sure that's the one I showed you earlier. Here, same thing, 1 through 6, null trunking on, right? These ones, it's where it's a little different, right? Because it does 6 and then 23 to 24. Yeah, that's pretty much it for the trunking. Let's go back to our here, and then we'll do spanning tree. So we'll enable spanning tree. Now how to do that? Let me actually go here. T spanning tree mode, and then rapid PVST. Let's copy that. Actually close that. Go here. So ensure all switches are running rapid PVST. That's what we just copied there. Configure core 1, switch 1. So this one right here. All right, so let's actually, they should all still be in global config mode. So let's paste that there, copy that. Scroll down on our map, and then we'll do spanning tree. I'm pretty sure it's VLAN ID. Let me see. And then we have a VLAN. Let's do 10, and then root, and then we can do primary to make it scroll up, and do secondary. So I'm pretty sure. Let's just copy this. Copy that. paste that here. Copy this, paste that here. And then we will basically copy, and then this is core switch 1. We'll do core switch 1 here. So switch 1 for 10, 30, and 90. 10, 30, 90, and then the other switch to be the secondary for each of the VLANs respectively. So this would be the secondary for 20. Copy. So it will be 99. Let's copy this again. Actually, let's remove this. Core switch 2. So this one's going to be 20. This one's going to be 99. That's 0. This extra one, secondary for 10. This one is 90. Copy this. Paste this here. And then we'll put 30. Alright. Now let's just confirm. So core 1 is the root for 10, 30, 90. Perfect. And it's the secondary for 20 and 99. Alright. Core 2 is 20. See? So you have to revise. So 20. And this is 300. That's not a VLAN that we created. So 20 and 99, primary, secondary for 10, 30, and 99. All right, perfect. Let's get to pasting this copy. Let's go on core. Let's actually just confirm it one more time. 10, 30, 90, primary. 20, 99, secondary. We're enabling, paste here. Do show spanning tree just to confirm. Ah, that's why. Let's actually create the VLANs, because that's funny. Scroll up. This is the good part of having these. It's funny because RSTP is actually on them. Copy, paste, do show net brief, perfect, and then do show span tree to see if. So RSTP, this is 1, we'll do 10. This route is the bridge. Scroll down. So we're 20. Ah, this is it should be secondary. Let's see. Core switch to secondary. Secondary. So only 10, 30, 90 should be primary for this. 10, 30, 90. So let's do do show spanning tree. This is LAN 1, LAN 10. This is the root. This is the root. Because we haven't enabled. Let me enable it first on the second one as well. You see, do show LAN brief. Same thing. Need to do that. So let's do. Do show LAN brief. Alright. Copy this. Paste. Do show LAN brief. Do show spanning tree. So the first one, LAN 10, this should not perfect. It's showing that it's not the primary. 20, it should be. This is the root. Yep. 30, no. This is secondary. Then I think 90. Yeah, 99. Let's double check it over here just to make sure. Do show spanning tree. So 10, this is the bridge. 20, it is no longer the bridge. Perfect. 30, this is the bridge, the root bridge, excuse me. And then this is the bridge here. The 99, it should be now. Perfect. So we did this. Give me 1 second. Let me just double check to see if there's any more misconfigurations that I might have missed. All right, I came back, enabled rapid spanning tree on all of the switches. Now let's do this one. Enable IP routing. So we're gonna assume they're in a global config. SVIs. All right, so interface LAN 10 IP add exit interface LAN 20 IP add exit interface LAN 30 IP add exit. I'm only doing it like this because I'm gonna scroll up and get their IP addresses. So this is just like the basic config, like a template we can use basically. Interface LAN 90 IP add exit interface 99 IP add exit, and just to confirm, LAN 10 exit exit exit. Not here. Perfect. And then we'll just do this. Core switch 1. Copy all of this. Copy. Core switch 2. Alright. Now let's scroll up and get the IP addresses here. So management 90 would be 10.90. Actually, here 10.99.0.1. Let's actually remove this, and then we'll just do 2 because it said the first one is the first available. Second, same thing. So 10.90.0.1. Let me finish this. They're all right. No, LAN 10 is /23. because it's a /23 for 10. So just to confirm, 10, they all match up to their plan. All right. So 10.10.1, first available, perfect. And then we'll just copy this. Go into here, and then we'll just change this to the second available IP. Right, as it said, let's scroll down here. IP routing. Perfect. So let's go ahead and copy this. Copy. Let's go to core 1. Paste this here. And do show run just to see. All right, and 10, 30, 10, 20, 30, 90, 99. All right, perfect. 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 Perfect and perfect. All right, now let's do the same thing for core switch 2. So then you can see IP routing is also enabled right here. So let's just go back to the VLANs. Second available IP address, perfect. And that's the amazing part of having MOPs. So server port configure, that's to be a 99. All right. So interface, let me see, switch port mode access, switch port access LAN, and then this one would be 90. And it's just SRV IP 10.90.0.10/24. So the gateway, that's pretty much it. And we've done all of these already as well. So let's just go here and get the interface. So it should be this one right here. So interface G1/0/24. Oops, let's not copy that last one. Copy. We'll go here. We'll do paste. Exit. Do show the plan brief. Here, server 90. This one right here. Perfect, and it's orange, so it's the correct one. Here we will go into here, into our MOP config interface. We'll do this 10.90.0.10/24 subnet. And then default gateway would just be 10.90.0.1. Alright, let's go back here and get our MOP out again. MOPs are amazing as well. We've done that. Core layer. Configure IP addresses on the point-to-point links between the core switches and routers. Let's see. actually do this and give me 1 second. All right, sorry, I'm back. I just had to enable an interface, two interfaces actually. Let's do this. All right. So configure IP addresses on the point-to-point links between the core switches and the core router. So let's see the configurations on switch. Let's do this. Switch core, switch 1, we'll do interface. We're on currently, this is core router 1, right? We're using LLDP, so this is the local interface. Core switch 1, this is the interface, so they both match up. All right. So interface G1/0/20, no switch port, IP add, and then we'll scroll up. So for now, we'll close this. It's a point. All right, we'll do 10.255.255. We'll do 1, and then 255.255.255.2. Core. To here, same thing. Since it's basically mirroring each other, this time we'll do the second one. So we'll do 5. So let's do this. Copy. Do here. Do paste. Show IP interface brief. And perfect. Alright. Do the same thing here. Copy. Exit do show IP interface brief. Perfect as well. And then let's just exit out of this one as well. It's always good to just have it in global config mode. Space. Now this one. So do one interface GA/0 IPN 10.255. I'm pretty sure this one is 3. No, it's 2. 3 would be the broadcast. So let's change that. Oh, I didn't even have to go there. I could just look up. All right. Exit interface G 9/0 IP add 10.256. That's the only one left in that range. 2. And there are no shut already, so we'll just do exit. Go into here. Paste. Do show IP interface brief. Perfect. 2 and 6. Right, now let's look at the other things. Enable OSPF. Alright. So this is still core. Let's just do this. Copy. So process ID. So router. SPF1. ID. So router ID, we'll just do 10.10.10.10 network 10.205.205.0.0.0. Remember, this uses wildcard mask, and we'll do area. Actually, no, not 3. We'll do 15 area because it falls in that range. Perfect. Advertise. Other devices are point-to-point interfaces connected. Do exit. And then so let's just see. So this should be pretty much the same for them. So we'll do core switch. And I think it should be good for both. Yeah. Switch. So router OSPF 1 network 10. Oh, we'll just do it like this. Oh, and I'm pretty sure it's the last one, so these should match. Area 0, so it's perfect. Let's do this. Copy. So that's 10. This is 20, 30, 90, 99. 20, 30, 90, 99. And just to see, 10, 20, 30, 90, 99, 10, 20, 30, 90, 99. All right, perfect. And then area 0, so that's advertising those, and then we'll add network 10.205.205.0. This one could be just a point-to-point, but we'll do 15 just for simplicity. 0. Let's see. Copy. Paste this in here. And we'll do end clear. This is just to have it clear. Process yes, and then do show IP pro or show IP pro. And now router ID. Perfect. I just wanted to reset it so I had the router ID. Let's go back here. Copy. And it's pretty much the same thing for both of them. Exit. Show IP. And then we'll give it a little bit of time for it to actually sync up. Paste. Exit. We will fast forward a little. All right, I think I went a little too crazy. All right, perfect. Do show IP OSPF neighbors. So we did 10, 20, 30, 90, 99. So it should have 6. Oh, see, 10, 20, 30, 99, and then this is the router ID. Perfect. Let's see here. Let me remove these interfaces because it's blocking me. The labels, I mean. Way easier. So let's see. 1, 10, 20, 30, 90, 99, and then that's the router ID that we put on router 1. do show IP OSPF neighbors 10, 20, 30, 90, 99, and then perfect. So we did that. Now let's do the DHCP services. So DHCP, IT staff LANs. So this one's also missing its default. We'll do 90 as well because it's missing 90. Copy. Control V. So we're just gonna assume we're in configuration, global config mode. So exclude used by the SVIs. So first we're gonna exclude them. So it should be IP DHCP. Actually, let me get the syntax correctly from here. N T IP DHCP excluded address, and then it's just the range, the low. Copy that. Paste that here. So it'll be 10.10.0.1, 10.10.0.2. Copy this. Do the same. It's 20, 30, 90, 99. 20, 30, 90, 99, and 99. Actually, let's keep that open. We might need it. And then create pools, use SVIs, and correct default gateway and DNS address of 8.8.8.8. Alright, so let's do IP, DHCP pool, pool name. Copy. Oh, let's get rid of that. DHCP pool, let's put LAN 10, network 10.10.0. And I'm pretty sure it just uses 252. Let me see. I'm pretty sure it just uses the regular one. 10. IPDHCP. 10. That's why. That's why I was having issues. So it's gonna be together. Right. Boom. Network. 192.168.0.0. And then I'm pretty sure it's just a regular mask. Yeah. So let's just test it out. Whoops. Alright, yeah. And then it's default router. Yeah. Send.0.1, and I'm pretty sure it's just DNS or DNS. Alright, and that's pretty much it for that. So let's change this. Alright, I'm gonna change this off screen because it's pretty much just copying and pasting. We'll actually configure them on screen as well as do the DHCP relay and verify that they're able to get them, their IP addresses on screen. So give me 1 second, I'll be right back. Alright, now let's do, just finished it. Let's do, we did this, default route, data server. Wait, 90 is, it's 99, it's management. So this would be perfect. Just confirm something really quick. Alright, we did. This one, let me see this one. Again, perfect. Alright. So now let's do the other part, which would be the SVIs. So we're in global config mode. So interface WAN 10 IP helper address and then it would be it would change actually. So let's see. Do show LLDP neighbor. Do show LLDP neighbor. Then show B08 connected to core switch 1. Core switch 1. 8, this one. Do that. Do the same thing. Copy. So this is 20, 30, 90. Since we did 99 statically, let's copy this and just have to, oops, copy that, paste that, change this to 6. We have to add exit to, that was me. Six, exit, exit, and exit. Exit, same thing here. Sorry. So now let's do this. Copy, Ctrl-C, and then paste this on. Do show IP. No, do show run. Excluded addresses 10, 20, 30, 90. We should remove this one. Yeah, we'll remove it in a bit. Let me just copy that. 10. Alright, perfect. DNS 15, 30, 90, and perfect. Now let's remove 90. Exit. No. And then we'll paste this do show run. Perfect. So 10, 20, 30, 99. Amazing. Here we'll do, copy this, paste that in here. Copy this. Paste that in here. And then we will see if they're able to get it dynamically. Config DHCP. Config DHCP. We'll wait a bit actually to see if we are able to. Is this one able to? Sometimes fast forwarding. No, it looks like it was not. Right, let's actually see. IP config / renew. Let's go into simulation mode. Renew. Let's follow the packet. Boom. Boom. Blocked by STP. So drops the packet. These should have configured as trunks. Should have, I'm pretty sure it should have been configured. That's strange. We'll do it again because it should still go through regardless. Let's just see. Alright, DHCP message is generated. Sent here. Just look at it. So it sends it out. All of its interfaces. Why is it not going through? Give me 1 second. All right, I'm back after some troubleshooting, and what caused it, the configurations were fine. I just reloaded the switch. Let me show you. All right, I saved the running config, did reload. All right, and then look, DHCP, perfect. Yep, and this is the only VLAN that was having an issue. The other VLANs I didn't even touch. They were able to get it dynamically through DHCP, and this is all of the clients. I'm only going to show you a few because we're almost done with the topology. All right. Here, did that, OSPF, did that, and here. The core, let me see. All right. Configure connects to the public address. So interface, we'll get that in a bit. IP add to 3.1, 255.252, no shut, exit not excluded address, right, core router. So let's see, core, it's fast Ethernet 0/0. that. Default routes. So let's do IP route to core 1 pointing towards the ISP. So O.O.O.O.O. And then this should be what? Since it's two, this should be 2. That one should be 2. So 2, 3.1.2. So that's that. Distribute. We'll do router OSPF 1 default. Let me get the syntax for it actually. Close these. Exit router OSPF 1 default information originate. So now this should advertise its default route to the other devices. Let's remove this here and paste that here. Let's get that stored. I mean, they stopped once the issue was fixed. I think this is when I reloaded it actually. So let's see. Paste. And then exit. Do show IP interface. It's brief. And conf T. And we'll just do this here. Interface G should IP 203.0.8113. I think it should be 2. Let me just make sure. Yeah, 2. No shut. All right, give me 1 second, okay? All right, I'm back. I didn't touch any of the topology, so let's just configure this. The last thing, and this we pretty much already did. We'll do this connectivity thing right here though. Just LLDP, we've been doing that the whole time. STP as well. OSPF. We'll show you, and yeah, we've showed you that as well. So yeah, let's just finish this network address translation. All right. So define access list all private to be translated. Exit IP access list. No, it's just access list 1. Access list 1 permit, and then do we do? Yeah, let's just do that. O.O.O, and then O.255.255.255. All right, let's just do this. Copy that. Paste that there. So that's going to permit all of the traffic coming from here to be translated outward. Perfect. And then here. So we'll do interface GA/0 IP NAT inside exit interface, because remember there's this connection as well. So G90 IP NAT inside exit interface fastly day 00 IP NAT outside exits. All right, and then let's do the final NAT configuration. Let's just do this IP NAT inside source list 1, and then interface, and then it's the outside one. Pretty sure it's the outside interface as well. Fast Ethernet 0/0 overload. That just to get the proper syntax. I'm pretty sure that's about it, really. This is all going to be configured on R1. Paste, exit, show run. So let's see. Perfect. It says and then let's do here just to see. Do show IP route. Oops. Perfect. And then this is the default route as well. Let's now attempt to ping the internet. I forgot what IP address. Let me copy that really quick. Copy. And then let's see if we are able to ping. So ping, we'll do inter-VLAN routing first, and then we'll ping the internet as the final thing. 10.20.0. Let me see. This one is 5. They should all be 5, I think, if I'm not mistaken. 4. All right, we'll do 4. Yeah. Which one did I have open? PC1. PC1. We'll do 4. Alright, and then we'll see confirming inter-VLAN routing. The first one should fail. We're pinging, I think, this one right here. So it looks like it's failing. Alright, so simulation. 4.20. Sent there, sent there, sent here. Sent out of all of its interfaces. Options, preferences. Did I? Is this the correct one? No, that's 5. Does 4 even exist? That might just be the issue. I don't know if 4 exists. Yeah, that may just be the issue that there's no 4. Yeah, that's really the issue that we're having. We'll do 5 because 4 is not something that actually exists on VLAN 20 currently. So let's see if the configurations again are good. And perfect. All right. Had me worried there for a second. 4 does exist on this one. We'll do 4 here. Scroll up. Change this to 4. Change this to 30. I think we're pinging this one right here. First one should fail. All right, now let's see 99. 99.4. All right. And we should get perfect. All right. Now ping, and then we'll paste that address, and hopefully we're able to ping the internet over here. Oh, there we go. Perfect. And just to confirm one more time. So NAT is working as well. Let's ping server. This one right here. I'm pretty sure it was 1090. Again, the first one should fail. Perfect. Whew. All right, so we've confirmed Inter-VLAN routing in here. So we're able to communicate from VLAN 10 to 20, 30, 99, as well as 90 over here, as well as NAT. So NAT works. So we're able to ping from PC1 here in VLAN 10 to go to, I think it takes this route right here, boom. And then this one has IP routing. It has IP routing as well as OSPF running on it, and it has a default gateway or default route that was advertised from Core 1. So do show IP route. This one right here is the IP route that is advertised from Core 1. And then Core 1 actually performs the, let me show you really. Let me show what it actually does. Because it's going to perform NAT there because we perform NAT overload. And we can actually flood the network with pings right now. Just to show you that it is working and it's using the NAT translation table. Hopefully, paste. Since we're here, we can do that, do that. So we're doing one in every different, do that. And then we'll show you the NAT translation table to show you that it actually is translating, excuse me. Are we able to ping? Yes, we are. 3.2 as well. We move that one as well. Cool. So they're all so here, let me show you, it's actually actively getting translated. Looks up routing table. Is a unicast, looks up the ARP table. The next hop address is in the ARP table. The ARP process sits. Oh wait, that's not it. Here it is. The routing table finds a route in the entry to the destination IP address. The destination network is directly connected. The device sets destination as the next hop. The device decrements the TTL, or time to live, on the packet. The packet is going from an inside to an outside network. The device looks up its NAT table for necessary translation. The packet matches an inside source list and creates a new entry in the source local address. The device translates the packet from local to global address with a matched entry. Right, perfect. And it is doing the same thing. Let's just do this really quick. We'll fast forward. Actually, not even fast forward. Let's just show you the NAT shape, the IP NAT. Or show IP NAT translations. See all of this, and then look, port number, port. And these are all from the inside global, and then these are the ones that I did. 10.10, perfect, see? And that's pretty much all for today, guys. It's been a long video. I hope you enjoyed it, and tune in for the next one. Thank you. Bye.